Start here. So this is a final bit from 13.5 on how to find dy dx.
I guess then again, he has like an Alex too. He has fever, or no, he doesn't have a fever. He has like symptoms of fever, but he doesn't have fever. Like, wow, I love it.
And remember, this section's on the chain rule. That's how we do in implicit derivations.
No, yeah. There's emergencies.
This is what you're
It's fine, don't worry about it. It's all part of the state. So yeah, there's money in the mistakes. Yeah, like it's like you're looking at like 6:30. Oh, who's the one thing that you do? You said that you weren't sure if you know the
I know the name of the end of
Oh, that was sad. Oh, sad, right? Oh, okay. Dude, you've been asking for like 4 days now. Like,
I was like,
4
hearing
days?
the I was like, it's like, do you not want a better grade? I have a good mind.
It's insane.
How did you do?
Oh, yeah. Oh, dude's like, yeah, I'm excited to talk to your grade, which is also my grade. You know, but, oh, well.
I'm not gonna be here next semester.
Read your strict instructions.
Huh? I don't even think she's gonna be here next semester. She's looking at colleges to transfer to. So.
Oh, what's the grade?
Well, transfer is, you have to, when you apply to
Oh.
transfer, you have to do it by next.
You're right.
By the next year.
Yeah, so that's actually the window's already
Yeah.
passed for
So
this
either
next-
she just won't be here next semester, or just won't be on campus.
Yeah, no, you're right. I forgot
Yeah.
about that. Yeah, that'll be for next year. Yeah.
Later then.
What? I guess I like know.
Oh.
Again, I could never.
You got it.
I try to get back.
Talking about
like,
Yeah.
that's it. That's something to do.
Uh-huh.
I get them.
Oh, okay.
But the thing is,
I don't remember that.
I think it's a program that I made.
Yeah.
If logic is true that a second is the highest value.
Uh-huh.
Yeah, so if
Going to find it, anything that's lower than the rate of.
Are you guys actually working on math? Like,
Yes.
stay focused,
There-
guys.
They're very multitasked.
Is that what we're calling not doing math in a math class? Multitasking?
Although I'd say I believe that multitasking is a non-existent lie.
Non-existent
just-
lie, I think that's a.
Yeah, that's all. Sorry, that was very. I think multitasking is quite practically a joke. You can they'll always put some more attention on one thing than another.
Multitasking doesn't mean an even split. But yeah, usually it's a lot more than it's like 90-10. You're thinking about the other thing rather than actually, you can't do more than one thing at once. Other than like chew bubble gum and walk.
Those things you do subconsciously, yeah.
So that's how we do implicit differentiation as a reminder. And y is a function of x. That's why we're doing a dy dx. So don't forget to do the chain rule.
I got dy squared dx. I don't know what.
What? You change it dy squared dx. Because that would have been, you would have had to multiply a dy by something, and technically you would have a dy squared over dx
I have
squared.
dx, dy, or dx y squared, or dx of y squared. Yes.
One more. We're glad you could make it.
There you go. I do this. Something broke.
Hopefully that's familiar. You guys have done this before. This isn't even really the next step. So what do we got? We taken the derivative with respect to x. We've got 3x squared minus 3y squared. And then minus, remember y is a function of x, so we got to take the derivative with respect to y. Minus 6xy dy dx.
This. This is dx. What do you mean?
Am I missing something, Jericho? Because I keep hearing you talking over me. I'm not sure what's going on. Is there something to add?
I'm talking to that side.
Oh, okay. So this was treated as, this came from a product rule right here. That was a product rule. And now we want to get dy dx by itself. We can move the, well, these things to the other side. That can move over. And if I do that, I've got dy dx times 3y squared minus 6xy equals 3y squared minus 3x squared. And if I want to isolate dy dx, I divide both sides by that value. And I get dy dx. It is important to note, and I wish I didn't have to bring this up, but I have seen this on tests. You cannot cancel the 3y squareds.
Well, one of them has a dy dx in it, so.
What?
Because because one of them has a dy dx, you can't.
A lot of freedom.
We're already, I'm talking about in this final step here. I've already factored out the 3 white. Let me re-put that step back in.
Oh, I don't want that. Yeah, no, you can.
Where's my good small, nice little black one?
You'd be a,
No, we can.
you'd be able to take out a
not-
three, right?
You're talking about, you can't cancel these
Right.
two. Oh, okay.
You should be able to pull a 3.
You can pull 3 out, but.
You can pull a 3, but not a 3 white. You can find, yes, there's a 3 in all of them. But you cannot cross off 3 white squares. I've seen this on exams in this class. I've seen this. Not even like replaced with ones. I've seen it just canceled out, like that's how, like they just go away. They're 0. That is not possible. That is not, you can only cancel shit out that's in a product or a quotient. That minus sign between them changes everything.
Just sound smart and maybe you'll make it through.
I'd probably do that.
But yes, we can cancel a 3. So maybe this is a little cleaner as y squared minus x squared over y squared minus 2xy equals dy dx.
Okay, now we're just talking about limits at this point.
No, we talked about quick.
That is not even 13.5. This is Calc 1, isn't it? Or did you guys do it in Calc 2?
Calc 1?
Yeah, Calc 1.
Yeah, so let's upgrade it. I just wanted to refresh your memory because implicit differentiation is something we don't do very often as a student. So does anyone need that up longer? I see people probably. I'll leave it at like another 30 seconds, and then we'll put up like one where there's, let's up the game to multivariable functions.
Think about gradient. Next, after this.
Oh, yeah. Gradients.
We are getting to the gradients. We'll do gradients in a second. Just want to make sure you guys know how to do implicit differentiation with chain rule. Why would I want you to know this? It might be on the test.
Says my.
It might be on the test, guys.
We like staying.
The one saying,
that was
the one who's
the
already made the test, is saying that he might be on the test.
We will not assume that. We'll just assume y is a y only. It's not a function of x. So just z is a function of x and y. It's the only thing that's a function of the others. No point in overcomplicating it. And here's your terrible math joke for the day.
That's pretty good.
Terrible. Terrible.
I thought it was honestly gonna be like a 7, 8, 9 joke.
That's what I was thinking too.
Like why was 6 scared of 7? I thought it was gonna be like something like that.
To be honest, same here too.
7, 8, 9.
So.
I don't think Trent knows he turned his camera on and then laid his head back down. Am I that boring, Trent? That's good to know.
Damn, exposed without doing that. Exposed. Exposed.
They can do this here when they leave their camera on.
Oh, you don't, you don't get it? No. Oh, okay.
Went to sleep too late on Trent.
At least he's got his mic on and he's listening because his head popped right up when I said his name.
It's a pretty bad joke, but it's.
Your joke fell flat on Eric.
He just he panicked for a second. He was like, "Oh my god."
Don't worry, Eric, you weren't missing anything.
Literally what I think.
I gotta say, part of the question.
No, it's like doing the regular derivative,
Hold up.
but when we hit Z, it changes.
Changing back to the yes. Not that.
Oh.
Yes.
This
What
should
exactly?
should they be impartials?
Well,
Of VDX?
I put it regular like this because it like regular X's, it hits it just fine. When I get to the Z's, I'm definitely going to write it as a partial like that.
Okay.
I think we got a little room with what we can put right there. A little wiggle room. That's just the first one. Let's see the second one. Maybe I'll go back to that notation again. ZX, like that.
That thing. Hey, why you have a- wait, wait, wait. On the right track?
So now I'm cleaning up a little bit.
Oh, you did that one first. Okay, that was.
Oh, is that Z sub X a partial derivative of Z of
Yeah,
ZX?
Yes.
Oh, that's what you would put. That's what you would put instead of, I put DX,
Oh.
yeah.
Yeah.
It's a parcel.
It does kind of look like a Z times X, so.
Let's see. I did that one. I did that one. I did that one. I need to do these two still.
I did something seriously wrong.
And now we get ZX or DZ DX by itself by division.
Well, I only got one partial. That's the problem. Remember to do the product.
What I can't believe Trent's like trying to. What else? I would hate waking up to a math lecture. Jesus, that is not a. Fuck that. I even like math, but having that as my, you're like waking up now. No. Yeah.
Good, a nice morning of math and coffee is very
That
healthy.
Professor Jones.
Math in bed.
Oh, you know what's a great alarm clock? Having an alarm clock that that will go off and you can't turn it off until you solve the math problem.
That's too much. Most people aren't operating that well early in the morning.
I mean, I've heard that there's definitely alarm clocks where you have to like it's a weight and you have to like do certain like amount of like stirrups or something, or like you have to like do weights with it a certain amount of times before it'll actually go off.
It's crazy. Trent's dreaming about calculus.
Get to practice it.
So now I did the derivative with respect to y. And kind of want to factor out the dz dy. So I'm looking at these have dz dy.
Wait, is that
and
not a
I-
key? Is that what I did wrong? I can't see, I'm blind.
Maybe you shouldn't be in the back all the time.
You just gotta understand that 20/20 vision, like.
Can you scroll back up real quick? I want to check something. That's all right. For the original like original. I'm dumb. I hate myself.
Oh, you wrote the problem wrong.
No wonder I didn't get an extra partial.
Don't worry, that's nice. That's why I double and triple check to make sure that I've written the problem right.
I just glanced at that question. I have to redo it. Last, it's a name.
Riding 100 miles a minute.
Oh my gosh. It's one of those. Oh, he just left. He left. Oh, he's back.
I'm right here the whole time. Did I
Oh.
disappear while I was holding? I did. Oh, it's like nothing.
It's the invisible cloak from Harry Potter.
I'm writing the next whiteboard. That's fucking slick. That was neat. Oh yeah, it's straight up invisibility cloak.
Wait, did you say you didn't know what Harry Potter was?
No, these two.
I'm not a Harry Potter fan.
I mean, okay,
They're
I didn't
they're
grow up watching
degenerates.
Harry Potter because my parents didn't like want me to watch Harry Potter. But even I know what Harry Potter.
Why?
They didn't want me to watch it. Yeah.
Watch it.
Oh, the books. Oh, I never.
Your parents didn't want you to watch Harry Potter?
Well,
Oh,
like
we
it's
gotta
like-
unpack that another day. That's
It's witchcraft. You can't.
That is witchcraft.
That means you literally
It
could
is
watch.
witchcraft that they're doing. Of course, they
Pretty
wouldn't
much
want
couldn't
me to
watch
watch
anything
it.
on TV then.
And even now that they're kind of like getting like, yeah, if you want to watch it, go ahead. Just know the reasons why we didn't want you to watch it. I really only watched 2 movies.
Did they think you were gonna start wanting to practice witchcraft by watching Harry Potter?
Well, maybe not
Well,
just
yeah, why
Harry
wouldn't you-
Potter.
Why wouldn't you wanna, why wouldn't you wanna do witchcraft?
Well, that's
Harry
not-
Potter?
That's not really the point. It's like not just Harry Potter. They would
As a
do
kid,
that for a lot of
as a
different
kid, I
things.
wanted to do spells.
Like, they start- They turned off a SpongeBob episode where SpongeBob was lying to sell a bunch of chocolates and was
I
succeeding.
watched it.
And they didn't want me to learn that it was good to lie because I would get what I wanted.
Oh, yeah, that's also a good point. There is a lot of lying.
This is when I was really young, of course.
This generation is so.
I can see why.
But how do you learn right from wrong? If you don't see the wrong.
Okay.
Oh,
They
That's,
don't
yeah,
want me to
that's
learn.
not, like,
They don't want me to
that's
learn
what
the
my
wrong
argument would be. Teach them witchcraft. If you want to say witchcraft is evil, at least let them know what witchcraft looks like when they see it.
Yeah, it's like you see this kid lies a lot and we don't want to do that. And that's why he's getting hunted by a evil
We
wizard.
need to teach our kids.
They had their
glorious
reasons.
rainbows, fairy tales, and la la land.
All right, you guys ready for some gradients?
That's not even remotely why he's getting hunted. It's like fairy tales, la la land, and rainbows.
I said it.
I wish it was what it was like.
Maybe we'll start with the easy one. Find the gradient.
Yes, the gradient. I think the fact that it's a vector
So for those of you that have not watched the video, the gradient in 2D is a vector ddx ddy. And if you're in like a higher dimension, like 3D, you would tack on like the ddz. But in this problem, it's only 2 dimensions, so we don't need the blue component. The gradient, this is called the del operator. And this is a vector maker.
I love Del or Zol?
Del,
Del.
D-E-L, like Del Taco. It's like Del Taco.
Me too.
I want to say it's the Greek letter nabla. I think that's the Greek letter nabla.
What's a novel?
It's a Greek letter. I said it like twice.
Well, yeah, but what does it look like?
The Del operator, an upside down
Oh,
triangle.
that? I didn't even know that was a Greek letter. I thought they just made it up.
That looks like a Dorito.
I don't know if it's a Greek letter. I know it's called nabla also. I don't know. I remember where nabla came from. But that's just all extra info, just so you recognize what this does. This takes a regular function that is not a vector and vectorizes it. Yes, vectorize. You type that into Microsoft Word, it does not come back as a spell checker thing. Apparently, vectorize is a word.
Wow.
The English language, it is
Right?
forever deep.
But my name
Deeper
is
than
in
you'll
that.
ever know.
It's a vectorizer. That sounds way better than the gradient. That's the name it should have been, was the vectorizer.
It sounds like one of like. Yeah, I know. That's what I was thinking. Sounds like something different would make. I guess it would be the vectornator though. Vectoriated. Oh man, what is it?
Wait, what's the
Oh.
beaver?
We need to use the chain.
I was only thinking of needs to ocean. Sandwich. Her last name's Beaver. Gradient. I don't know.
And while you're writing, and once you have that equation written down, I'm going to show you why we give a shit about the gradient. Some of the many uses that we will do later on. Let's motivate learning this
I
thing
swear
because
I swear that's E. That has to be E. That's an exponential.
This time it's actually.
Okay.
The x squared y cubed above the e is an exponent. That is an exponent.
Yeah, you guys out here having like 20, 25 minutes. Go be in.
That's like what kind of business I actually have. I always forget.
The task. of the
So
use-
I just don't, like, I'm short distance or short-sighted.
Short-sighted, does that mean you can't see close to you?
No, that means I can only see close to me.
No.
Yeah.
Far sighted, you can't see close. Short sighted, you can't see far.
Yeah, it's about.
Yes,
So one of the uses for the gradient is there is a potential function phi. If you take the gradient of the potential function, you get a conservative vector field. And as we will do later at the end of the semester in this class, and you'll also see in physics, there are plenty of vector fields like the magnetic field, the electric field. Then we also have stuff that we will do repeatedly is the divergence is the gradient dotted with F, and the curl of F is the gradient or the del operator cross product with F. So, and these are used throughout chapter 15. They're great for three-dimensional physics and other three-dimensional tasks. So this gradient operator is really important. Just wanted to show you where we're going.
For me,
I want to use this in physics or something.
No, you don't.
you don't. Don't worry.
Cool idea, but when you actually have to use it, very. Oh, yeah, it's a very, yeah. That's me and my face. This is why I get rid of the photos.
I applaud you for trying to take a physics class with the appropriate calculus class, but I definitely would not sympathize. I definitely wouldn't want to sympathize. I've already done the thing.
Like, they can say, no, it's a conspiracy. I like conspiracy.
It is not a Greek letter. Nabla comes from the Hellenistic Greek word for a Phoenician harp. It is the delta symbol upside down. It looks like a harp, and so they named it Nabla.
It looks like a heart.
Harp, H-A-R-P. Harp.
Oh, I see that.
Oh, it looks like a heart. I thought you said it looked like a heart. Like last time I checked, my heart's not a.
That's why I said it again, because you clearly didn't hear what I was saying. Harp.
You have 2020 here.
The audio quality is.
Sometimes it's the audio quality. Sometimes it's I'm trying to talk over you. And so you're hearing your own voice over like the instructor.
The voice in my head.
Very sure that's not the voice that's going out loud.
So what do we get in the I hat direction? I get y(e) to the x squared y cubed cosine of x cubed y squared plus, now I'll do that. I've got 3 sets here that have y's in or x's in them. That's got x, and this has got x. So we got a product rule going on 3 times. So I took the derivative of the first one, the xy section. Then I'll take the derivative of the exponent. So I will, derivative of the exponent is 2xy cubed. So I will have 2xy cubed times xy e to the x squared y cubed cosine of x cubed y squared. Then we got to do the cosine. This is going to result in a negative 3x squared y squared. Well, the 3x squared y squared, and then the negative comes from switching to sine. So this cleans up a little bit. I'm gonna factor out. I can definitely factor out an e to the x squared y cubed. We'll start there. And I've got y cosine of x cubed y squared. And then I've got plus 2x squared y to the fourth cosine of x cubed y squared. And then I've got xy sine of x cubed y squared. Maybe I'll make that a square brace. It looks like I could factor out a y as well. That's more work than I want to do rewriting it right now. I guess I could do it. Just erase. Lose a y there, lose a y there, and drop that by a power. There we go. That wasn't too bad. And that's my I hat. I have a minus sign in here. That's a minus. Yeah, I'm making these problems exceptionally a pain in the ass with product rule because I've seen that it needs to be done. Not everybody's proficient in product rule.
You know, I did.
The X,
It's like it
the
didn't
last
taste
X
bad.
component, the sign,
I
what,
did forget
whatever,
about the.
you need to double check the sign one.
Sign?
Yeah. He
Oh,
left
I got
that,
more shit going on there. I dumped a bunch of shit.
yeah,
I dumped
3x squared, 1 squared.
that's x cubed.
Oh, because you forgot
Then
that.
sine x cubed y squared. There we go. I had left out that part right there.
Okay, I see what you did. I see what you did.
That's because you squared.
Makes so much sense.
Doesn't matter.
Let's see.
I learned messing since that.
Let's see.
Like here, the better pun master than Mr. Jones himself.
Yeah, just keep it down.
Now we'll do j hat. Again, 3 parts. You know what? I'm tired of writing the E. So from henceforth,
Doesn't exist.
E the x squared y cubed is going to be listed as smiley face.
Oh, that's even more work though.
It takes up less space on the room. You don't have to do it. That's just what I'm going to do. So I'm taking the derivative. Where is it? Of that. I've got x smile, or yeah, I'm taking the derivative with respect to y. So I've got smiley face. Wait, yeah. And then cosine.
Don't forget about your.
And then I got to do the middle term. I'm taking the derivative of x squared y cubed with respect to y. It's 3x squared y squared. But I have an xy out front already, so this should be x cubed y cubed. Smiley face. Cosine of x cubed y squared. And then we do the sine or cosine to sine. We are pulling out a x cubed or 2x cubed y. 2x cubed y. And I had an xy already. So I'm going to have a 2x to the 4th y squared. And it's going to be minus because we're switching the sign. I've got a smiley face. And then I've got sine of x cubed y squared. And in the interest of not wasting time factoring there, I'm going to leave that as is. But you could let's just write it so it looks like a real word, David. Could factor out X smiley face.
Yes. Yes.
I like how the smiley face is kind of looking at the X like, we are best friends.
You should see a therapist. What kind in particular? Might I ask?
Yeah, there's psychoanalysts, humanists.
Yeah.
There's like all kinds of different therapists.
Yeah, that's what I asked.
There's even like there's group therapy. There's you can even like not even get professional help and just go to like a self-help, like Anonymous.
Mhm.
There's all kinds of different therapies.
Yeah.
You should be more specific.
I don't need to be. This is a math class.
I'm sure. I think a mental asylum would work.
I think that's getting me better and keeping it contained.
We will be doing more with gradients. Well, Monday is entirely continuing on the gradient theme and other things we'll do with it. And where it's good for, what it's good for. In terms of what we've been doing lately, if you haven't watched the videos yet, we've been doing partial derivatives in directions like I hat and J hat. And well, no, we found when we were doing vectors, we don't want to always do I hat, J hat, K hat. Sometimes we have a moving object and we want to keep our thing relative to that, like a position on a curve. So we want a different coordinate system. So we want to be able to take the partial derivatives in any direction. And so the gradient is a tool that lets us do this. So this is switching away. The gradient helps us get away from the IJK coordinate system.
Mr. Jones.
Yeah.
So just because like I'm starting to get like a little confused. Is this still utilizing the chain rule, or is this not doing that? I'm confused.
You just use the same.
I did not do the chain rule. I did not say anything was a function of another letter.
But if we, okay. So
This could, if we have like y was a function of x, we could have had a chain rule component to it. We're not doing that.
okay.
No point in needlessly complicating it. But we will be doing a lot of stuffs with this del operator.
13. Tomorrow's 13.7.
Well, then you mean Monday?
Oh, it's Friday, no, never mind. This all it's like a solid over, so you watch it.
I will not be at Starbucks this weekend. I'm going to Oregon tomorrow for my mom's funeral. So there's no Starbucks this weekend.
This was just
With me, you guys are more than welcome to continue the Starbucks thing without.
Part right here. Remember that anytime.
I will still be holding my SI tomorrow as usual as well.
Front of it, you had to leave that part alone, so that becomes 2xy cubed. and then you're just basically.
Oh,
tacking
Mr.
on
Jones.
everything else that was
Yeah.
beforehand.
You remember
you
how
have to
yesterday I
do
talked
the
about how I
equation
was thinking of
and then
moving my SI hours,
everything else in the
moving
equation.
around my
my
SI
thing is,
hours
like,
a little bit
so
now
Yeah.
that when I pass semester
X
class?
to the third.
How much time does it take to get
So
that set in
why-
stone so I
this
can
X
plan
would
out
be
when
X.
I should send out like something?
No,
When I
because-
should
wait, no,
start
no,
or
it-
figuring
it's
out.
still
what
bringing
that's
down
how that's
the
gonna
same
work.
It couldn't
Like
be
we can
because-
start
but-
talking with
that.
Ashley right now about when and where you want to do it. That way we
basically
can
be
start
saying,
checking
like,
on a room.
Okay.
Right here, you're basically.
Because
saying this is
the
also
idea
like
is that
X to the
I've
X
already
to
since I've already
the
set
power
up
two, so you couldn't
my
just
timesheet
multiply that out.
for until the 15th. I can't really
Right,
do
you
it
wanted to do it
until-
after that.
Yeah, that's the idea.
So we just bring this.
Right, but we can
Uh,
start setting up now for that.
Okay, then I will make another announcement. I have another announcement. If you guys would listen, I'll be sending out sometime maybe this weekend some type of form. I'm going to be changing around my I hours a little bit. And if you guys have any requests for different times that I could be more available to
You're
you,
basically just doing
that's
the
the
same
idea.
thing, because remember, this is like that part stays the same. 'cause this
I'm
is-
changing them around
this is
because
just
I have a half
change
semester
the
class,
problem when you're trying
so I'm having more
to-
time on
You're basically
Wednesdays.
doing the exact.
So
same
I'm
things here,
gonna
and
move
just
my
multiplying
times a little
each
around to make it more.
part. So if
Can't
you
wait
see,
for that class ends.
if you see,
Yeah, like even on Monday, I'm hearing like,
you see
I'm
hearing like the physics class kind of run through my SI hours on Monday
the
as well.
derivative
So
of each
I was also thinking of
individual
changing that
component,
too.
part of it, 3 times, but what that also involves is that. you
Right, we
have
never
to
did the
tackle the
K-hat.
rest of the equation as well.
Well, there was no K had to do. It was in
This is why
terms
these
of,
values are
Oh, I see.
But the rest of the,
So,
the rest of
I was,
the rest of the
wondering
equation.
about the
is the
notation
same except the
a little
part
bit,
of the equation.
on the very, like, right after you have your f of x, y,
Does that kind of? make sense?
Uh,
Yeah.
it
That's
says
why
like
this
d
stays the
dx,
same.
d
I don't know,
dy,
I guess
and
I'm
then it
confused
has
about
the
that because you
function,
brought the
and like
the y
brackets, it has
cube down,
d dx.
so the same thing, just
Yeah,
you're
like
not
that
doing
first.
the-
Lorenzo, can you come closer to the camera? I can't hear you over Jericho.
Oh,
Right
that's
under
why
the
this
top.
stays the same.
Yeah, exactly, yeah.
Oh my gosh.
Yeah.
Okay, absolutely. Okay, that makes sense.
Not your fault.
So what's it called?
No,
Right
yeah,
under
yeah.
where it says vectorizer.
Yeah, well, it's because we're doing
Okay,
in respect to X.
Why does it have a GDX and a DDY right there? I'm kind of like confused on that notation.
We put it in component. form.
that's coming from this.
Why isn't it a partial of X and partial of Y?
That's a really, well, cause
And then that's why you.
I
keep
fucked
the-
up.
If you're not.
Oh, okay.
Oh, okay. I was
That
actually
part,
wondering-
you're
All right,
gonna
yeah,
get
cool.
So it's only just that. Yeah, so it's only
That makes
two.
sense.
It becomes, and it's just like that if you had like e to the 2x, right? It would just be, yeah. But I guess the reason why it was weird is because like, I'm not used to the exponent.
thanks for letting me go through the whole problem before pointing that out, Lawrence. You suck.
Well, I thought it was like something like, I thought it was correct at first, but then I was like,
Oh,
I was like, why? is it-
Sorry, Mr. Gent, I thought it was intentional as well.
No, it's a mistake.
Does that mean
Have a
it's
good weekend,
not-
guys.
Huh?
So this is wrong then?
Oh, no, just the fact that you put. Like regular.
I had regular DDX and DDY. I didn't show partial.
Yeah.
It was just my mistake.
Yeah, oh, well, then, yeah. you probably-
I thought somebody was-
But the biggest thing is.
Yeah,
we need to
no, I
figure that
understand.
out.
Because I thought maybe like, with very,
I was thinking that
That's
was
why
also
it's good, it's
intentional,
good to
so.
do that, but
I
just make
thought
sure that
vectorization maybe like, right, like that.
attention you.
Yeah, that's just a fuck up.
That makes sense?
Never mind.
It
Sounds
happens.
good. I like your background.
So where you
Living in the forest.
Thank you.
What
Something
are those
peaceful.
trees? Are those like redwoods?
Yeah.
I think so.
If you would have went to the astronomy, field trip.
I mean, I've seen redwoods before.
Yeah, do you want-
I've seen them plenty of times.
Astronomy field trip, you would have known, without a doubt.
You guys going to map art?
Yeah, I got work right now. Have a good day, Professor Jones.
Wait, you're going to map art?
You have a good weekend, guys.
Oh, I gotta
Thank you. Have a
go.
good weekend, Professor Jones.
I'll see you guys.